how to predict the units of K. This is something my high school students struggle with. So I teach in Manheim Township. Manheim Township, even their CP Chem program is pretty crazy. Boy, I have taught at 3 different schools, and I can tell you every school is different. It is crazy how what's the word I'm looking for? It is absolutely insane the rigor that different schools have. Like, oh, I mean, but at a township, the curriculum is nuts for chemistry. It's like those kids hit college chem though, they know what they're doing. I didn't write the curriculum. I just started teaching. Anyway, how to predict the units for the rate constant K. My high schoolers really struggle with this. My college students usually they're more mature. It's not too bad, but it is a little heavy. So here's how we do this. Okay, hang in there. You'll get it, hopefully. Let's write a generic rate law, just one reactant, right? We don't need to make it any more complicated than that. Let's say we have one reactant. So rate equals K times concentration A to the X. Rate, and you need to memorize this, at the end of the day, the units of rate need to be molar per second. Molar per second. So I want to predict what the units of the rate constant K have to be, depending on the overall order of the reaction. Well, let's say the overall order of the reaction is 0 order overall. If I'm 0 order overall, anything raised to the 0 power is 1. So I'm 0 order overall. I need to get molar per second as my units for my rate. So I need the rate constants units times 1 to give me molar per second. Well, that's pretty obvious. I don't have any units here if it's 0 order. So K's units have to also be molar per second. So for a 0 order overall reaction, the units of the rate constant K have to be molar per second, or molar times seconds to the negative first, because you can bring that seconds out of the denominator and rewrite it in the numerator by making this exponent negative. So if something is 0 order, the rate constant has to have units of molar per second so that I get molar per second for my rate. What if the reaction is first order overall, though? Okay. Well, if I'm first order overall, the units of the rate have to be molar per second. And if I'm first order, that's molar to the first. That's just molar. So what times molar gives me molar per second? Well, think about it. This has got to be 1 over seconds. Because if I take 1 over seconds times molar, I get molar per second. So for a first order overall reaction, the rate constant is going to have units of 1 over seconds or seconds to the negative first. That's how we would usually write it, because we can pull that out of the denominator. So first order overall reaction, your rate constant K is just going to be seconds to the negative first. Let's try second order overall. At the end of the day, rate has always got to be molar per second. So what units times now I'm molar squared is going to give me molar per second. But now you really got to think. I need to actually get rid of a molar. So this got to be 1 over molar times seconds. Because if I do 1 over molar times seconds, one of the molar cancels out, and I'm left with molar per second. So this, if I'm second order overall, my rate constant is going to have units of 1 over molar times seconds, or molar to the negative first times seconds to the negative first. I want you to try third order using this method, predict what third order should be. Then go back and look at the problem we just did, because that one was third order, right? Okay, so try third order without me leading you through it. All right. End of the day, rate's got to be molar per second. So what times molar cubed gives you molar per second. Well, now I need to get rid of 2 molars, 1 over molar squared times seconds. So K has got to be 1 over molar squared times seconds, or molar to the negative second times seconds to the negative first. Yeah. Yeah. And that's what we got. We got 230 molar to the negative second times seconds to the negative first, if you actually pay attention to units and keep them going throughout. You can kind of start to see a pattern here, right? Fourth order overall would be 1 over molar cubed times seconds. Fifth order would be 1 over molar to the fourth times seconds in the denominator. Starts to get a pattern. Okay. Hopefully that made sense to you. If not, go back and watch it again. Right? Once the posting's there, because that really helps you check your answer when you're done. And I do the units of the rate constant is going to be worth a point. So I want you to really try and get them right. So in the kinetics unit, we're super picky about the units. So the nice thing is when we get to the equilibrium unit, chapter 13, the next chapter, equilibrium constants don't have units, but rate constants do. So you gotta super picky with these.